Hi everyone, this is the notes for lesson 5.5 on angles of elevation and depression. Okay, so we have that angles of elevation is the angle that's formed with a horizontal line and the line that goes below. So an example would be this angle right here. So here's my horizontal line and the line that goes below it. Okay, so this angle between those two lines, depression. The angle of elevation is formed with a horizontal line and the line that goes above it. So horizontal line, a line above it, so angle of elevation. So if we take a look at the two diagrams below that, this is just another example of what it would look like, but also most of these are word problems. So we'll have a person standing somewhere, and then this line that would be right there is their line of sight. So this is in this chapter because if we drew a line right here, what would happen? Good, we'd get a right triangle, and then we can do all of our magic trig functions to find whatever side or angle or whatever that we're missing. Okay, so if it says that it has an angle of depression and we have an observer, then the line of sight would be this line that's going down. Okay, so let's take a look at the example in the bottom. Basically what we're doing here is determining which angles are elevation and which angles are depression. So if we take a look at angle 1 from the bird looking at the person in the hot air balloon, is that angle that's between them angle of elevation or an angle of depression? Very good. Here's our horizontal line and we go down, so it's the line below it, so that would be depression. So what about angle 2? The person, if they looked up at the bird, is that elevation or depression? Good. Horizontal line, and if we're going up, elevation. So go ahead and pause and try to figure out angles 2 and angles 3. Okay, so I hope we got that angle 4 was another elevation, and angle 3 is depression. So angles 1 and 3 are depression, and angle 2 and 4 are elevation. Now that we got what angles of elevation and depression look like, let's take a look at our examples and read our word problems, because those are everybody's favorites. Yay for word problems. So our first one says that we sight a rock climber on a cliff at a 32-degree angle of elevation. The horizontal ground distance is 1,000 feet. Okay, and we want to find the line of sight distance to the rock climber. So here's our ground. Our angle of elevation to our person that's climbing a rock is 32 degrees. How did I know to draw the line above it? Very good. It said angle of elevation, so we know we're going from the horizontal line up. And our horizontal line in this problem represents the ground. Okay, so I'm going to drop a line straight down to be able to make our right triangle. So our cliff would be really steep. Okay, so the other thing they told us in this problem is that our cliff, the horizontal ground distance to the cliff is 1,000 feet. So if this is our ground, that's the horizontal line we have. So that line segment is 1,000 feet. So what are we trying to find? Very good. We want the line of sight distance. And if we look back at the diagram on the front, it said that our line of sight distance would be this line right here. Okay, so our line of sight is the hypotenuse of that triangle. So that's the thing that we're missing. So if we go back and use what we learned in lesson 5.3 with sine, cosine, and tangent, we can put opposite adjacent hypotenuse labels on our sides and then see if it's sine, cosine, or tangent and work from there. So I'll help you set it up and then you can go ahead and solve it. So hypotenuse is this one. We already talked about that. Opposite or angle would be this side. and we got nothing over there, so we're not using it. So that would leave this 1,000 to be adjacent. So which trig function are we using? Very good, cosine. So go ahead and write your cosine equation and come back and I will show you the answer. Okay, so I hope you paused and solved out that problem. This was one of the ones where you first had to multiply by x and then divide by the cosine. So we end up with that the feet is 1,179.18 feet. Okay, so let's take a look at our next example. So this one says that we're standing 53 feet from a windmill. Your angle of elevation to the top, so we have elevation again, is 56.5. Then they tell us that our eyes are 5.5 feet above the ground. Okay, and we want to know how tall that windmill is. So this one's a little bit different because they tell us kind of where our angle's being measured from. If they don't tell us that, we're assuming that we're measuring from the grounds where our feet are. Okay, but this time they said that our feet, or our height, or your eye level, is 5.5 feet above where the ground is. So that means that our angle of elevation comes from our eyes. So it would be like this. So this is where our angle would go. I'm going to clean that up a little bit. Okay, so if they tell you what your eye level is, then that means that you have that extra number, that 5.5, to take into account for your problem. Okay, so your triangle is kind of floating in the middle of the air. So we're going to have our windmill over here, and this pole right there, that weird rectangle box thing, that represents my windmill. I don't know how to draw a windmill, so that's the best you're going to get. Okay, so we want to know how tall that windmill is. Well, all we know is that from there to there is 5.5, but what we don't know is this part of it, that x. The other thing we knew was that we are standing 53 feet to the windmill, from the windmill. So that line is going to be 53. So that's like a ground distance. So from there we can label opposite adjacent hypotenuse and solve for x by writing a sine, cosine, or tangent equation. So go ahead and pause, set up your problem, and then come back and you can get the answer. Okay, I know you haven't paused yet. Pause it. Okay, welcome back. So, luckily this one, the x was on top, so we didn't have to do all those extra work like steps that we did on the front. And we can just multiply by 53, get tangent, or take the tangent of it, and we get that the windmill, well, this is what we get from the tangent. But remember, we had this piece right here that's 5.5, so you have to add your height into it. So that's why the windmill is 85.57 feet. If you have any questions on that, remember to write them down so you remember to ask me next class. Okay, so let's take a look at the next one. This one's a little bit different. So it says to approach the runway, they must begin descent 3 degrees angle of descent. Okay, so we're starting at a height of 2,714 above sea level, but the airport is at 1,070 feet above sea level. So what does that tell us? Well, it tells us a couple things. One, this airport is not in Florida because Florida is at sea level. Well, most of Florida, some of Florida isn't, but that means that they're not going to have to go all the way down to 0. We only have to go to 1,007 to get to the airport. So how much feet down are we going to have to travel? Well, to figure that out, we can subtract where we're at and where the airport's at to figure out what's going to be left. So we're going to have to travel 1,707 feet to get down to the airport. Okay? Since they told us two different numbers. That's why we had to do that. So let's try to draw a picture and then we can figure out how far the runway is from the airport. Okay? So this time, are we doing angle of elevation or depression? Good, it's an angle depression because we're going down. Okay, our airplane's over here. And we're going to make a 3-degree angle of descent. Okay, so this would be the ground. So that 1,707, where does that number go in our picture? Good. That is the vertical distance. That's how high our plane is. So that would be like the distance here, but it's going to be the same over here. Okay, so 1,707 would go right there. So now we need to figure out where our x is going to go. So it says how far from the runway is the airport when we start going down. So how far from when we start going down is the airport? Well, this is the airport right here. So we would be measuring the distance between them. So that would be this horizontal distance. Okay? If it said how far does the airplane have to travel, that would be this line because that's where the airplane's going to travel. So go ahead and set up your trig equation and solve for x. Okay, so we got that the plane went from when we begin descent to that it's 32,571.50 feet. So that is how far from there to there. Okay. So our last problem, I want you to try to read that one on your own and then draw your picture. And when you come back, I'll talk you through it. So I'm going to talk through it, and then if you need more help, you can ask me next class. Okay, so go ahead and pause. Okay, so for this one, we're talking about a 26-degree angle of depression. So I know that I can draw my triangle with the horizontal and then angle of depression going down. Okay, so there's my 26. It says that the altitude is 3 kilometers. So that would be how high the plane is above the ground. So that would be this side over here. And then we want to know what the airplane's surface distance is to the life raft. So if my plane is here, the surface distance is how far apart they are. So if we think about like if it's a helicopter, like how far would they have to travel to be able to drop a rope down to where the life raft is, okay? If they were a regular airplane, it would be this long would be how long it has to fly to get there, but that's not what they asked us. They asked us for the surface distance. Okay, so if you need help drawing your picture, there it is. Pause it and solve and get x. Okay, welcome back. Here we go. We got that x was 6.15 kilometers. Okay, so good job. Thanks for watching. Werner out.